Good afternoon and happy Friday. I apologize for not being able to be with you today, but I trust that this video will be of a help to you in understanding the distributive property and understanding your moving your math forward. So we've been in a review series this week with first covering order of operations, and PEMDAS being a very important part of being able to solve an equation, which is our end goal. Next, we got out the algebra tiles and we talked about combining like terms. And we saw that when we had the green rectangles that represented x's, we could add up all the x's, and when we had the yellow tiles, we could add up all the units together. So if we had something like x plus 2 and plus x plus 1, this would be one of the x's, this would be one of the x's, this would be 2 yellow tiles, and this would be 1 yellow tile. And that we could not combine an x with a 2 or an x with a 1 because they were not like terms. Never quite got that far to putting it numbers with it because we ran out of time. But the idea with combining like terms is that you can combine x terms with other x terms and single numbers with other single numbers, but you can't combine x terms with single numbers. So one more example, if I had 3x minus 2 minus 4x plus 1, you could combine your x terms, and just keep in mind that the operation stays in with the term itself. So this would give me a net of negative x. And then you could combine the single numbers together and you get minus 1. So combining like terms was our middle of the week lesson. And now today for Friday, we're going to work on distributive property. So here the blanks that should be entered in would be equivalent expressions. Are expressions that have the same value for all values of the variables. So taking a look at this first example here, I mean, yes, what they're saying is correct, but I find that confusing. What we're saying in terms of those algebra tiles that I mentioned, to say 3x plus 2, well, how would I represent x plus 2? I'd represent it, there's an x, and then plus 2, right? There's a 1 and there's a 1. There's x, and there's 2 more. That's x plus 2. Well, to have 3x plus 2 is to have this unit 3 times. Okay? So there's 1, 2, 3 times x plus 2's. So if I were to combine like terms, how many x's do I have? Well, I have 3 x's. And how many plus 2's do I have? Well, how many plus 1's do I have? I have a total of 6 now, okay? Because I have this 2 group 3 times. So I'm going to have plus 6. Okay? Let's do another one. Again, I don't like the example that they have here. I think it's confusing. Okay? What I would rather you do is you have 4 and 2, which is 6, and you have it 3 times. That's what that means. So what do I have a total of? Well, this is 6, and this is 6, and this is 6, so I have a total of 18. I think that's easier to understand. Let's move on down further, because there's no variable in those examples, so I think it's actually more confusing. So what they're wanting you to see here is that you're taking this 3 and you're multiplying x 3 times, and you're multiplying 2 3 times. Again, with algebra tiles, what I'd want you to see is here's x, here's plus 2, and here's x plus 2 3 times. So what I really have is 3x plus 6, right? I have 3 x's, and I have 6 yellow boxes. Well, that's the same as 3 times x and 3 times 2. Let's take a look at another one. Let's imagine the r is x, okay? So I have x, and I have minus 4. Remember, to do a negative, you do red, the red side. Now, how many times do I need this x minus 4, or r, we can call him r. Put a little r in the box instead of an x. It's the same thing. It's the variable tile. How many times do I have r and minus 4? Well, I have it twice. All right. So now I have it 2 r minus 4s. So what do I have? Well, I have 2r. And how many negatives do I have? I'll have 8. And I have negative 8. That's important. So if you look at this, 2 times r is 2r, and 2 times negative 4 is negative 8, because negative times a positive is a negative. All right. This, however, this style with the algebra tiles does not work when there is a variable up front. You just have to know to multiply n times. So n times n and n times 6. Well, we know that the little exponent is there, and when you have two numbers or two bases, two of the same base being multiplied, what do we do with their exponents? Well, we add them. That's a bit of a higher order. If you can't do number 3, don't worry about it. Your turn. Here we go. X plus 3 2 times. X plus 3. And you're doing it how many times? You're doing it 2 times. Now combine like terms, and what do you have? You have 2x plus 6. Do the next one. We have 2 units. They did the units first this time. And we have a negative variable. It's not green because it's negative, but it is still a rectangle because it's the variable term. Now we've got to do this 8 times. And I know that's a lot of drawing. You don't have to necessarily do the drawing, but I want you to see it. All right, that's 2. That's 7. All right, that's 2, and negative x, or negative n, what negative variable, 8 times. I have to do it 8 times. So now, how many of the negative variable do I have? Oh, I have negative 8 n's, and I have plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 of the unit tiles. Okay? Now, I can just take 8 and multiply it times 2, and 8 and multiply it times negative n, and I'll get the same answer. Let's do one more. So again, I have y, And I have plus 2. How many times do I have that? I have it 4 times. Positive y, positive y. And I'll stick it long ways this way. Positive y plus 2 for each one because I have y plus 2 4 times. So ultimately what I have is 4y plus 8, which is the same as 4 times y and 4 times 2. Alright, you pause the video and do the next 3 problems. Okay, assume you've paused the video and you've done the next 3 problems. Now let's check our answers. So I'm not going to draw these this time. We need 4 6 times, which is 24. And we need minus x 6 times, which is negative 6x. We're going to have n times n, which is n squared, and n times negative 9, which is minus 9n. And we have 3m times m, which is 3m squared, minus 15m. All right, let's try coming down here. Now we have that negative 2 in the front. So how does that work? Well, with the algebra tiles, it's hard to show without the expression that how it's negative, and then you'd have to flip it up. So at this point, hopefully you're just confident that you understand it's x plus 7 2 times, but then it's also, each of these are negative. So I will show you that it's x plus 1, 2, 3, 4, 5, 6, 7. But it's that expression, and I'm not going to forget the negative sign, 2 times. 4, 5, 6, 7. Okay. So now, that's how you express x plus 7 2 times. But it's negative. So therefore, this whole expression needs to go red. And this whole expression needs to go red. If they're positive, you turn them red, negative. And if they're negative, oops, I'm drawing it with my finger as I'm saying this, you turn them positive. They're all positive, so we're going to turn them all negative. Okay? So what I really have is that. That gives me negative 2 x plus 7s. All right? So what do I have combining those terms? I have negative 2x, and I have negative 14. And how does that work if I simply multiply it out? Negative 2 times x is negative 2x. Negative 2 times 7 is negative 14. Okay? Here they want you to just put the 5 and the negative y in here. But what you're doing, because they have a variable out front, it doesn't work nicely with the algebra tiles. It would be a lot more complicated. So if there's a variable out front, simply just do the multiplication. This gives you negative 15y. And, gosh, they had to do this the hard way, didn't they? So this is where you need to see that it's, remember, if it's a variable tile, right, this is, we can call this y instead of x. It's just the variable tile. How many variable tiles do we have there? Well, 1, right? 1 red, negative red tile. So you understand that when you have negative y, what you're saying is I have negative 1y, because there's 1 y tile there. All right, so let's take this in pieces. Y times y is y squared. 3 times 1 is 3. And negative times negative is positive. And you're still bringing down the subtraction sign. So you don't have to write that positive. This was a very complicated one. I'm not sure it was necessary for you guys at this stage, but there it is. So you have negative 15y minus 3y squared. Let's look at the next one. The next one's a little easier. All right, so we have 2x minus 11. Okay, let's do that. How many times do we have 2x minus 11? Well, we only have it one time. Yes, it's a negative one time, but still one time. So we're going to draw 2x and minus 11. So it's got to be red because it's negative. All right. Now, because we have negative one of these, then you have to flip to the opposite. I have negative 2x, and I have positive 11. We have to distribute that negative sign. So my final answer is negative 2x plus 11. Okay. Okay, now we have the your turn. Let's take a look at what we have here. I'll do the first one with you, and then I want you to pause the video and do the next couple on your own if you can. If not, you can just do it with me. So we have n plus 4. Again, n just means the variable. It could be x plus 4. It could be z plus 4. It doesn't matter. It's a variable plus 4. It's an unknown plus 4. So therefore, we're going to use the variable tile plus 4 individuals. Okay? And we're going to do this 5 times. The whole package has to be done 5 times, so not just the variable tiles, but we also need to do the unit tiles 5 times. There is the n tile 5 times and the plus 4 5 times. Now, it's not just 5 times, but it's negative 5 times. Therefore, this is actually red. Because it's negative, you have to turn it negative. And these are red. Okay, you're distributing that negative side to every tile in the group that was in the parentheses. So once you're done distributing that negative sign to every single tile, what do you now have? Combine your like terms. Well, I have negative 5n, and I have negative 4, 8, 12, 16, 20. Okay, let's look at that just numerically. I have negative 5 times n is negative 5n, and negative 5 times positive 4 is negative 20. All right, at this point, I want to encourage you to pause the video. You try them on your own, then come back and unpause the video, and I can do them with you. You can check your answers. All right, so I'm hoping that you at least tried one of them on your own. Here we have positive 4, and we have one negative variable tile. Okay, and we only have this one time. You can see it just says negative out front. So what does it mean when we see the negative tile, the negative sign out front of the parentheses? It means to turn everything the opposite. So all the positives become negatives, and the negatives are now positive. So what's our final answer? It is positive y minus 4. So let's take a look at that. Negative times 4 is negative 4. Negative times negative is positive, so it leaves me with positive y. All right, let's try and look at the next one. Here, again, we have m minus 5. We have it 3 times, but we also have a variable involved. And we have to use our exponent laws that we learned at the beginning of September. So m times m is m squared. Always will be. So we have 3m squared minus 3m squared. And then we have negative times negative is a positive. 3 times 5 is 15. And then m. Let's take a look at the next one. Here we have negative 3a and negative a squared. Negative times a positive is negative. A times a is a squared. Okay, we have negative, well, we have 2x. This one is easier to show with the tiles. There's 2 x's. And we have minus 11. And how many times do we have this? Only 1 time. But we have it negative 1 time, which means we're going to turn because of the negative sign out front of the grouping symbol, we turn our positives into negatives and our negatives into positives. So now what do we have? We have negative 2x plus 11. So we distribute that negative sign again, we multiply. Negative times 2x is negative 2x. Negative times negative is a positive plus 11. All right, one more. We have a negative variable tile and plus 9 unit tiles. And we had to distribute a negative sign. So you turn it positive, negative goes to positive, positive goes to negative. So the answer is 1d minus 9. Negative times negative is positive, so that's where you get your positive 1d. And negative times 9, positive 9 is negative 9. All right, now we're going to have multiple steps. So here we have a symbol outside of the grouping symbols. Now, there's nothing to do inside the parentheses because with PEMDAS, you do what's in the parentheses first, right? There's nothing to do in the parentheses because these are unlike terms. You can't combine them. The next thing we have to look at is the E, which is exponents. We couldn't do anything in the parentheses. And there are no exponents. So the next thing we can do is the group of multiplication and division. All right? So there's not, I can multiply this 2 times the 6x and the 2 times the negative 4. Or I can look at it as 6x two times, right? And negative 4 2 times. So as you're seeing, drawing algebra tiles can be very tedious, but they're good visual. Now, the other thing we have to add in is 1 more plus x. Okay? So this is 6x and minus 4 2 times. There's 6x minus 4 and 6x minus 4 2 times. And plus 1 more x. So how many total x's do I have? Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 x's is what I have. And how many unit tiles do I have? I have 1, 2, 3, 4, 5, 6, 7, 8 units, but they're negative units, right? They're red. So my total is 13x minus 8. Now let's look at that from a numerical standpoint. If I just multiply 2 times 6x, I get 12x. And I multiply 2 times negative 4, I get negative 8 plus x. Now I can add 12x plus x is 13x and minus 8. And notice they are the same. Alright, I want you to try this next one. Pause the video, try it on your own, and then we can do it together. Alright, so I'm just going to multiply this one out for sake of time. Negative 2m, negative 10, and bring down the minus 4m. It's very important that you remember to bring down the minus 4m. We can sometimes get focused on distributing the front term that we forget the back term. Now we're going to group like terms. So this is an m term and this is an m term. Oops. So we're going to group those together. What's negative, if I am in debt 2 and then I'm in debt 4 more, I'm in debt 6. And bring down the minus 10. Okay. Let's try number 3. Now the trick is here, what is being distributed and what is being, how do I look at this problem? Well, I want you to mentally group. This is a positive x. This is a negative 3. So we're distributing a negative 3 to each term. So I'm just going to bring down the loose term that's by himself. Now, negative 3 times x is negative 3x. And negative 3 times negative 4 is positive 12. Now, in PEMDAS, I couldn't do anything in the parentheses because they're not like terms. I couldn't group these. There were no exponents to deal with. Then I did the multiplication division step where I multiplied the negative 3 to both terms. So now what's left is to add and subtract like terms. So x minus 3x is negative 2x plus 12. I know it's a lot of steps, but it really does get easier the more you practice. Promise. 2 times 4a is 8a. 2 times 1 is 2. Again, don't forget to bring down the a. You get 9a plus 2. If I were to do this with algebra tiles, this one's a little easier to do because it's a little less drawing. I have 4 variable tiles in 1 unit. And how many times do I have this package, this 4 variable tiles in a unit? Well, I have it 2 times, so I got to draw it one more time. And then I have a plus a, which is 1 more variable tile. So all together, what do I have? Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 A's, which is what I have here, plus 2 unit tiles, which is what I have here. So 9A plus 2. Go ahead and pause the video, work on number 2, and then you can start the video up and check yourself. Okay, I have 2 unit tiles and 1 negative variable tile, which is what the minus c is. How many times do I have this package here? Well, I have it 3 times, so let's do that. But let's not forget, I have 1 more negative variable tile. So now I combine all my like terms. What do I have left? What do I have total? Well, I have 1, 2, 3, 4 negative variable tiles, and 1, 2, 3, 4, 5, 6 unit tiles. Now, why didn't I flip them colors? Why didn't I turn the yellows red and the reds green? Because my 3 was not negative. When I'm distributing a negative, the negative means the opposite. It means flip to the opposite, okay? But this was a positive 3, so therefore I just had to add up what I had. All right, let's take a look at the next one. I'm just going to do, you can do the algebra tiles if you like. I'm just going to go ahead and do the numbers mathematically. I'm bringing down the 6R. Again, there's nothing to do for PEMDAS. I'll check off my steps as I go. There's nothing to do inside the parentheses because they're not like terms. I can't combine them. There are no exponents. So now I'm to multiply and divide. I'm going to multiply 2 times R and get 2R. 2 times 4 and get 8. Now I'm going to combine like terms. Here are my R terms. So 6R plus 2R is 8R and plus 8. How'd you do? All right, let's move over. Number 4. Here, seeing how these terms are grouped is going to be important. You have to see this as like distributing a -1. You're distributing the negative to everything inside the parentheses. So what's inside the parentheses is a variable tile and 4 negative unit tiles. Now I'm going to distribute this negative sign by flipping. Remember, that means flip. Okay, but now I also have 15 positive, and yes, I'm going to draw all 15 because it's important for you to see I have 15 positive variable tiles, and you need to see that 0 pair. Remember him? Pair means 2. So there's, let's see, 1, 2, 3, 4 is 12, 13, 14, 15. Okay? So I have 1 0 pair. This makes 0, so I'm going to cancel them out. So what do I have left? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 T tiles, and plus, this is why we don't use the variable T because it looks too much like a plus sign, plus I had 4 positive unit tiles. Why is it positive? Well, because remember we distributed a negative to it, so negative times negative is positive. How did you do? All right. Distribute -6 times V is -6V. -6 times 1 is -6, plus, bring down the V. Now combine like terms, -5V minus 6. Six times 5 is 30. 6 times -Z is -6Z plus 2Z. Combine like terms. 30 minus 4Z. And there you go. All right, I think that's it. Pretty sure that's it. Hope you guys have a great weekend. I'll see you Monday.